Hi guys, myself JEHOVAH Fernandes. I am a civil engineering student from GIRIJABAI Sale Institute of Technology, Karwar. In this video, I am going to show you the foundation design for a building using a safe software. So let's start. At first, open the safe software and click on new model. Now click on the design code and select IS456-2000. Now for the design preference, modify and show. Select the cover as 50 and the preferred bar as 22 as mentioned in the problem. And click on OK. Now select grid only as the initial model. Now select the grid lines in the X direction as 19 as per the problem. Also in the Y direction as 19 and the grid spacing as 1 meter each for both X and Y direction. Now click on OK. So here you can see that the grid lines as mentioned for spacing of 1 meter and 19 number of lines has been appeared. Now click on define and select materials. Click on add new materials and put the material name as M40. Select the material type as concrete. Now put the weight per unit volume as 25. Modulus of elasticity E as 31622.7. Now keep the Poisson's ratio as 0.2. Now change the coefficient of thermal expansion as 0.0000455 and keep the shear modulus as it is. Now change the compressive strength as 40 since it is M40 grade concrete, in which 40 represents the compressive strength, and click on OK. Now click on add new material and select and name the material name as HYST 500. Select the material type as rebar. Now select the weight per unit volume as 77 and modulus of elasticity E as 2 into 10 to the power of 5. Now select minimum yield stress Fy as 500 and minimum tensile stress Fu as 545. Click on OK. Now here you can see that both the HYST 500 and M40 has been defined. Click on OK again. Now click on define and select slab properties. Here you need to define the slab property, that is footing. Select the property name as mat footing and select the slab material as M40. Select the thickness as 500, which you need to change later. Click on OK. Click on OK again. Now click on define and select column properties. Click on add new property and write the property name as column 500 into 500, which is the dimension of our column. Next, select the material as M40 and write the dimensions of the column, that is 500 and 500. Click on OK. Now add another column which is 600 into 600 mm. Write the property name as column 600 into 600 mm. Select the material as M40 and write the dimensions, that is 600 into 600. Click on OK again. Here you can see that both the columns have been defined. Click on OK again. Now click on define and select soil subgrade properties. Here you need to define the soil property. Click on modify show property and select the property subgrade modulus as 3 into 10 raised to 4 and click on OK. Click on OK again. Now we need to define the loads. Click on define and select load patterns. Here you can see that already the dead and live load have been defined, which is by default. Now click on load cases and select the load case type as linear static if it is not. Now go to define again and select load combinations. Here you need to click on add new combo. Under this, select the load name as dead and the corresponding scale factor as 1.5. Similarly, the other load name as live and the corresponding scale factor as 1.5. Under design selection, select only strength ultimate and click on OK. Now you need to define another combination of load. Click on add new combo and select the load name as dead. Now the corresponding scale factor should be 1 and next load name is live. Here also the corresponding scale factor is 1. The design selection should be as service, service initial, service normal and service long term. Click on OK. Here you can see both the combination have been defined. Click on OK again. Now go to draw option and select draw slab areas. Here select the property as mat footing. Now draw the slab area by joining all the 4 corners of the grid lines which was defined earlier, like this. Now here you can see that the area has been formed above the grid lines. Since this area is very much close to the columns and that there should be minimum spacing between the footing edge and the columns, so we need to add extra spacing between the footing and the column. Click on edit and select edit areas, under which select expand shrink areas and select the offset value as 2000 mm, which is equal to 2 meter. Click on OK. Here you can see that the initial area has been expanded to 2 meter on all the sides. Now go to draw and select draw columns option. Under this, select the property below as none and property above as column 500 into 500. Height below as 0 and height above as 2 meter. Now carefully draw the columns on the footing area. All the columns except C6, C7, C10 and C11 are 500 into 500 dimension. So draw the column except C6, C7, C10 and C11 like this. The column should be at the spacing of 6 meter as mentioned in the problem. Now that all the columns of 500 into 500 dimension has been drawn, click on draw again and select draw columns. Now select the property above as column 600 into 600 and keep rest of them as it is. We will be drawing the column 600 into 600 now on C6, C7, C10 and C11 like this. This completes the drawing of the columns for the building. After the columns has been drawn, now we need to draw the design strips along the columns. Click on Draw and select Draw Design Strips. Here, select the strip layer as A and the slab design type as column strip. Select the start width right, start width left, end width right as 4 meter. Now, draw the design strip along X direction as shown. Now, change the strip layer to B and keep rest of the things as it is. Now, draw the strip along the Y direction as shown here. Now, close the draw design strips. Go to Set Display option and select Labels, Show Width and Show Stations and click on OK. Here you can see all the strip lines. Now go to Set Display options again and deselect Labels, Show Width and Show Stations and click on OK. Now we need to assign the soil property to the footing. Select the footing area. Added down, you can see that one area and 4 edges has been selected. Click on Assign, select Support Data and select Soil Properties. Click on OK. The soil property has been assigned to the footing. Now we need to change the rebar material for all the strips and the footing area. We'll change it by right clicking on the strip and selecting the rebar material as HYST 500. Click on OK. Repeat the procedure for all the strips in both X and Y direction. Similarly, we need to change the rebar material for the footing. Select the footing area and go to design and select the rebar material as HYST 500. Click on OK. Click on OK again. So, the rebar material for all the strips and the footing area has been assigned. Now comes the assigning of load for all the columns. Select column 1 carefully. Select C for the selection at the bottom. Now go to assign and select load data, under which select point load. Select the load pattern name as dead and put the load as mentioned in the problem. Don't forget to change the dimension to 500 into 500. Click on OK now. Here you can see that the dead load has been applied to the column. Now for live load, again select the same column and select assign, under which select load data and select point loads. Change the load as mentioned in the problem and select the load pattern name as live load. Here you can see that the dead load and live load has been assigned to the column 1. Similarly, repeat the procedure for all the columns. After completing, click on Run and select Run Analysis. Here you can see that the software is performing the analysis for the footing. Here comes the results of the analysis. Move the cursor anywhere to see the different displacement values. Now go to Run again and select Run Analysis and Design. Now go to Display and select Show Punching Shear. So here we can see different punching shear values, but these values should not exceed 1. So we need to change the thickness of the footing. To do that, first unlock the model. Now go to Define and select Slab Properties. Here we need to change the thickness of the footing. Click on Modify Show Property and change the thickness from 500 to 1000. Click on OK. Click on OK again. Now go to Run and select Run Analysis and Design. Now go to Display again and select Show Punching Shear Design. So here also some values exceeds 1. Repeat the procedure and change the thickness of the footing. First unlock the model. Click on Define. Select Slab Properties. Click on Modify Show Property and change the thickness from 1000 to 1200. Click on OK. Click on OK again. Now go to Run and select Run Analysis and Design. Now go to Display and select Show Punching Shear Design. So here you can see that all the punching shear values are not exceeding 1. Hence, the footing thickness which was defined as 1200 is OK. Now go to set display option and select extrude view. Click on OK. Now go to 3D view to see the extruded view of the footing along with the columns. Now select the 2D view and go to display. Select show strip forces. Here you can see different forces such as moment, shear force and so on. Click on layer A and click on apply. Now if you move the cursor along the strip line, you can see different moment values. Similarly, you can see the moment values for layer B also. Also, you can see the shear force values for both layer A and layer B for different types of load, that is dead load, live load and the combination of dead and live load. Now go to display and select show slab design. Here click on impose minimum reinforcing and select layer A and click on apply. Here you can see the different values by moving the cursor along the strip lines. Similarly, now select layer B and unselect layer A and click on apply. You can see the values by moving the cursor along the strip lines in Y direction. Now go to display and select show slab forces stresses. Here select any combination of load and select M max, that is moment maximum. Click on apply. Here you can see the maximum moment applied on the footing. Similarly, change the component from Mmax to Vmax and click on apply. Here it shows the shear force values, maximum shear force values of the footing. Now go to run and select run detailing. Select all the three and click on OK. Here you can see the detailed view of the project. The figure displaying is a footing plan. Now go to rebar table where it shows detailing of the rebars. Now click on rebar schedule and see different details. Similarly, click on rebar plan. Here you can see the rebar plan. Zoom to see it properly. Likewise, you can see the full details of the footing by clicking on each of the mentioned below the detailing. So this completes the design of the footing. Hope you guys liked it. Thanks for watching.